Hey everybody, Shawn here from the Automation Blog and School, and in this episode of the Automation Podcast, I meet up with Matthew Dulcey from PROCENTEC to learn all about their SNAP Industrial Ethernet Fault Identification System. Matthew, thank you for coming on the Automation Podcast and taking time out of your busy schedule to sit down with us. Now, before we jump into your presentation, can you take a minute just to tell our audience what your role is at the company?
Thank you, Shawn, for having me. Absolutely. My role at PROCENTEC is as the Chief Technology Officer, and I have, I am an American living in Europe since 2013. I started at PROCENTEC in 2014, and I actually started on the commercial side. And with my time at PROCENTEC on the commercial side, I got to say I was very fortunate to visit 22 plus countries globally and see industrial automation operations all the way spanning from Australia and Singapore into Africa, all over Europe, and as well as in the US. And then it was about 3 years ago that I moved over to the technical side because based off of my experience on the commercial side, I was very fortunate to have some very innovative ideas that can be applied to making field technicians' lives easier.
That's awesome.
Yeah, thank you. I appreciate that. So, Shawn, if it's okay with you, I would like to just explain to your listener base somewhat of what PROCENTEC does and how we do it, but maybe I'm going to take a little bit different approach than you're used to. From my experience on the commercial as well as the technical side, I really would like to explain to your user base how and why we have a portfolio that looks as it does. Is that okay for you, Shawn?
Yeah, that works great.
All right. So for your users, I want you guys to take note of the first line here, which is Industry 4.0 Human, and it says realized. The realized is obviously just a little piece catchy, but the key part of this is Industry 4.0 Human. When I had the field experience that I had, the one main theme that kept coming up repeatedly is for a lot of our users in the field, they hear the term Industry 4.0 and everyone thinks, robots, autonomous vehicles. Some technicians feel that at some point they're not going to have jobs anymore. And at PROCENTEC, what we feel is that the challenge isn't going to come from the technology side, that the human is not going to be taken out of these industrial operations, that the human is actually the star, believe it or not. And that when we're designing solutions, we try to come at it from the standpoint of, if I'm a field technician or a support engineer, how should a product work and why is it beneficial to me? I don't know if that makes sense to you, Shawn, that, Industry 4.0 might have to be modified a bit, if you get what I'm saying.
Yeah, no, I agree with that wholeheartedly. I think that the person is always the key. They're always the key to the process. So yeah, please.
Yeah, and the person has to be, because just as I'll say, tip my hat to these support engineers and field technicians. Why it matters, as I always say to people, is I'm very proud to work with those technicians and engineers that keep the lights on, keep the wastewater flowing, so to speak. I certainly don't want it backed up into my house. But also, people in steel, automotive industry, pulp and paper. All these are critical industries that for everyday life we should be thankful we have, and we're a small part of that. And I'm going to talk about starting with what are the main challenges that those field technicians have in their operations. But I'm going to start with what is the troubleshooting process. I don't know if you're familiar with this, Shawn, or if you've ever sat down and actually thought about what is the process that a technician has to kind of follow. But I'm going to just walk you guys through that. So the troubleshooting process has 5 steps to it that a technician that we use to simplify what a technician goes through. And the first step is errors or actions occur. I want to pause for a second there because I don't know of any system currently that can say with 100% certainty that they can prevent errors or actions from needing to occur within an automation network. And this error or action is typically what we see either, say, a poor installation, something that was missed during the setup phase, or it could just be the environmental factors that occur in factories. I mean, some of the facilities I've been to, you're dealing with very acidic solutions, you're dealing with high temperatures, you're dealing with products that might only last 8 weeks because, hey, it's not a pretty environment to be pouring steel. So the technician themselves must walk through this process and an error action occurs. But the first step to getting to the fifth step, which is obviously repairing it, is you gotta have the right data access. So what we mean by that is you have a network, but the question is, how do you interact with that network as a technician? And how do you get data out of that network to help you perform an analysis of what occurred? Now, in some cases, you can do this preemptively or preventively, but in a lot of cases, it could just be a breakdown on the fly. Oh, something happened, a cable snapped, it finally, the signal finally degraded to a point where it just is gibberish for the PLC. So we have to access the data. The technician has to then perform an analysis on the data. And then once they determine, okay, this is where the error is coming from, they can create a strategy for what's the best repair path. And then obviously the last step is make the repair. And to say it, I'm going to say it lightheartedly, but it's actually not for the field technicians. This is rinse and repeat. We see this over and over again in networks. And how do we know this? Because our support technicians follow this exact process. I'm simplifying every step, but this is the process they follow to get to a solution. Does it make sense, Shawn?
Oh, it makes 100% sense.
Great. So now I'm saying to you, as a field technician, this is the process that you're following, but that's not the only challenge that you're seeing. A much bigger challenge that we like to see or say is the knowledge experience pyramid. Now, you can see some weird colors in the pyramid, and that'll come into play in a few seconds here. The key of this is that any operation, what we see looks like a pyramid, as in there's very few fully qualified, very experienced technicians at a facility. In general, in the middle level, there's qualified but a little bit less experienced technicians. And then at the lowest level, you would have a very broad base of general technicians that are, say, lesser qualified and lesser experienced. Now, why this matters is because what we see in the current environment, the current automation environment, is that what this means is that operations still need fully qualified, very experienced people. So what they have a tendency to do is bring up the pyramid qualified people, but they don't have such experience. And then they say these individuals should be in the driver's seat, so to speak. But then they oftentimes promote lesser qualified, lesser experienced people. And, maybe they're underqualified, and I'll explain to you why they would be underqualified in the next slide, but just take it for what it's worth. And what this leads to in most operations is severe staff shortages. But the thing is, when you're at an industrial operation, staff shortages occur, but you still need to operate. So you see that a lot of the industrial operations that we are involved in are constantly having this churn, and they're constantly short of the necessary labor, and that labor may be short of knowledge. Shawn, is that something that you think your users are also seeing, or your viewers are also seeing?
Yes, absolutely.
Okay. So why does this matter when I say lesser qualified? Well, in general, it's because We believe that a technician operates on the left side experience level from basic to expert, and that's a function of the time and experience that that technician is at a facility. Expert level knowledge is a combination of both. So what we see is to learn one industrial protocol in general takes a technician, say, 3 to 5 years full time to become an expert on a specific protocol. So a specific protocol I'm saying might be PROCENTEC. It takes 3 to 5 years to do the official training and get certified. It takes 3 to 5 years of field experience to see different errors that occur in a network. And during this period, we all like to believe our technicians are expert level knowledge, but in general, we see the typical operation, a new resource, is more towards the basic level and time experience. The reality of the situation is this is where an operation wants to be. They want to be expert level knowledge in the shortest amount of time. So now we're going to move towards how do I apply that concept of Industry 4.0 human to get that technician there. And I'm going to start with the basis of PROCENTEC's portfolio, but then focus on a specific solution that we developed that's commercially available. And that'll give you kind of completing the circle of why this matters and how changing your thinking for your field technicians can have massive value for any operation. So let's just go with the PROCENTEC portfolio really quick. We have our industrial protocols on the bottom, and to simplify this, let's just say there's a straight line to the controllers, and the field technician is typically looking at the SCADA system to get that information out of those networks. On our Profibus side, we have a suite of solutions that is all tied together with diagnostics. The ProfiCore being for mobile diagnostics. Again, how do we access the data? That's what I talked about in the second step. We have a ProfiHub and a Combrix, and the Combrix is for permanent monitoring. And a user can view the Combrix web browser, and they can see the diagnostic data for the networks below. On the industrial Ethernet side, we have a platform called Osiris, and Osiris can be delivered permanently in a solution called Atlas 2, or Osiris can be on the software as a service side, delivered on a user's laptop, or as a license on a hardened tablet that we provide to the users called Mercury. And the Atlas or any of these can interact actively or passively in a network. I'll explain just briefly what active or passive is and why it matters. Then we have a layer of solutions we lay on top of that that ties this together, where we call it Snap Analysis. Snap Analysis stands for Synthetic Neurologic Analytic Processor. Basically, what we've done, we've taken the knowledge of our technicians and we've digitalized it. So we connect this Atlas unit to an algorithm. The algorithm gets a file, and the file is limited to only the data that's relevant for determining what the error or fault is. And then the user can interact with the Atlas via the protocols such as OPC-UA, MQTT, HTTPS. And we have Osiris Enterprise, which allows you to see multiple Atlas units in the field. And then with Industry 4.0 Human, we also tie in two additional services, Lockbox and cVerify. Lockbox is a play using blockchain to help digitalize files. And then the digitalization of those files allows the user to have a certain amount of security that their file is indeed authentic. And then cVerify is a guide. It's a guide program where you can digitally create a guide and deliver it to any mobile device, Android or Apple. And then the user can just follow the guide in the field, and following the guide in the field, they can also take pictures, upload videos, follow the steps, see demo images of what they should be seeing in the field. And then once it's documented, the field technician that's remotely can then exactly see what the user is basically seeing, but in a guide format. So I'm going to move on to two things that I specifically wanted to talk about, which was active and passive. This is just an example of how an Atlas would be connected to the network, active and passive. And Specifically with active and passive for the users at home, what I want them to know is that an active is basically us polling the network and asking information of the devices. I always try to say to a user, this is like your doctor. When you sit down at your doctor, the doctor says, tell me, how did you sleep? How do you feel? Are you eating? And they ask you a whole bunch of questions that are as active polling. But then you have the passive side, and there's a device that I call the ether tap that's listed on there. And the ether tap sits in line, and the ether tap is essentially when your doctor sends you for a blood test. The ether tap is passive data that allows the doctor to fill in the information. And without the active data, having only passive data doesn't give you a clear picture. In general, though, what we see with our technicians is about 70% of the network errors we see in industrial Ethernet, you can solve with active-only diagnostics, and 30% you need to have a combination of both. With Osiris, we like to say, okay, what can you get and how does it immediately help the technician? So first is obviously a network overview, which is key. But then we can add to that the important items such as communications, but also security aspects. It's important to know who's in your network and when. And then on protocols that are specific or matter, Profinet and Ethernet IP. And those protocols for Ethernet IP, that's mainly obviously in the North American market because it's dominated by Rockwell, and Profinet for the European market, that's also dominated by Siemens. But we actually see that these markets quite often are industry defined more than they're market defined. So for example, food and beverage, it's not uncommon even in Europe to see Ethernet IP. And in pulp and paper, it's not uncommon in the US to see Profinet, mainly because a lot of the equipment for pulp and paper is coming out of Europe. And then last, we have some additional licenses for EtherCAT, or the ability to tie in the Profibus information directly into Osiris. So let's just quickly get towards the communication chain for Snap, and then I want to talk about what we can do with Snap analysis and how we fulfill that promise of Industry 4.0 human. So we'll start tying it back together here. So for the communications chain, the first thing you got to understand is you're going to have a factory I/O network, and below the controller, the design of the network is an Atlas unit with a tap. And then on that, we're going to have the facility network. Typically, for security reasons, we see that users connect the Atlas unit on a VLAN or a vendor network. And then within that facility network, they go to a switch somewhere within a network. And then on that switch, they're going to have a secure VPN gateway that's also connected to all the Atlas units. This is connected to the Snap platform on the global network. The file that we're creating is a combination of no actual production data. This is key because what we see is security-wise, users want to know what's going on in a network when an error occurs, but they don't want that to require all traffic to go off-site. So no actual production data goes off-site. We're only taking a file that is relevant to the communications aspect. So this means device information and or error messages that are tied into the protocol. We deliver it into the Snap platform, and then from the Snap platform, the user gets a result into their office network. The field technician then sees the result either on their laptop or they can see it in the SCADA system. And then with that result, they can clearly understand what's going on in a network based off of the likelihood, what we like to say, a confidence level. So in other words, they're going to get back a result, and the result's going to say, okay, we believe that the chance this error is a 25% chance it's this error, 25% chance it's that error, 50% chance it's this error for this specific device or communication. It could be a physical layer media, or it could be, for example, a device. And what I mean by the identification is This is an example of two different networks. On the industrial Ethernet side, we can help automatically determine network flooding, network settings or interference, issues on copper, fiber, or Wi-Fi signals, device hardware issues or settings that are maybe not right in your devices. For Ethernet IP, we could specifically call out DLR issues such as settings, cabling, or devices, or priority message issues. And on Profinet, we can help decode automatically GSD files, determine if there's MRP ring issues, cable length issues, or fiber issues for POF. And for the algorithm, we can identify 45 plus common errors. And then we also link to that 175 device GSD files. So you can already see that for us, for defining Industry 4.0 human, we're saying here is Industry 4.0, but the field technician is now getting a result using that technology. That result, those 45 plus common errors, helps you more quickly identify what's going on in a network. It helps you solve the problem more quickly, and it really helps to guide you through to getting to that root cause. As I mentioned in the 5 steps, that we can now apply this concept to the 5 steps. So let's give an example of applying this. So an error in action occurs, and what we say is the time to the next step is typically 0 to 20 minutes. What this means is that when an error action occurs, you could be sitting at the SCADA system. Maybe you went out to get a coffee, you come back, there's an error in action, and that could be 0 to 20 minutes, or you get an email or a text message. So now the field technician has to access the right data. Now, in general, what we say is you have a combination of mobile and permanent. This is under options. And you can also access the data actively or passively. And our field technicians have also spoken to the field technicians out of facilities, and they say in general, if you have a mobile solution, it's typically 15 to 60 minutes for you to get out into the field, plug in, and start to get data that's relevant to identify. If you have a permanent solution, it's typically 5 to 15 minutes. The 5 minutes is I need to find the right network, log into the device, say an IP address, and then begin to perform the analysis. And as I mentioned in industrial Ethernet, active measurements is typically you can identify what's going on 70% of the time. Again, think of your doctor. 70% of the time, the doctor can prescribe or identify what sickness you have by just asking you a series of questions and doing very basic level tests. 30% of the time, the doctor is going to also have to do a blood test. To do the analysis is anywhere, say 20 to 30 minutes of actively looking at different data in the system, and message-wise, it's 45 to 60 minutes. And then the best repair path, it might take you 45 minutes to say an hour and 15 minutes. This is what our technicians say to determine how best to repair it. Now, you might say that seems strange, why it would take so long, but it really doesn't. Because if I have a network that has an error in it, and now I know why that error occurred, I then have to say, okay, what tools do I need? Do I have the products? How am I going to do this? Do I have to make changes within the PLC or the device? Do I have to get logins for the switches because there's unique passwords? And then last, I have to make the repair. And what we're saying is that could be as short as 30 minutes to days. So once I have the best repair path, to repair something might be only 30 minutes. Now, when you're talking about Snap, I said I wanted to tie it together with value. So if we know that we have a platform that can automatically decode network information, and the network information, I need to be very specific. The network information is only the device communication information, not the network data as in production data. We have to start thinking about this and applying this in value. And the first value that I like to say is technician value per hour. So if I needed to have coverage for my facility 24 hours a day, 365 days a year, at least in the European market, I need about 4.9 technicians. 4.9 technicians come from that in general, Europeans work a little bit less than Americans, we'll put it that way. And based off the average working hours, 40 hours a week, vacation time and everything, and then taking the average salary of, say, a technician in Europe, this means to have full-time coverage, every hour it's costing you as an operation around 26 euros and 15 cents. Doesn't include for the inflation we're seeing right now, but hey, we do our best. But if I have a system like Snap Analysis, again, applying Industry 4.0 Human, how do I make your humans better? You can now have 24 hours a day, 365 days a year coverage for about a euro 71 an hour. That's value. It's a significant amount of value. So if we start with the chart about knowledge and getting people to expert level, you have now got that coverage for a euro 71. And then if you apply it to why does it matter? So let's just say I had an operation. This was a steel operation. The lost revenue for an hour and a half downtime was around 117,000 euros. That was based off of the number of minutes that the amount of revenue they would lose per minute. And then, well, what can we recapture here? Well, we can't recapture the error occurring, that 0 to 20 minutes, and we can't really recapture the repair. But what we can recapture is the amount of time it takes you to identify and the amount of time that it takes you to analyze and then the best repair path. And what we see is with a product like Snap, we can reduce that downtime and actually recapture about 63,000 euros in revenue. And where we're getting that number is, again, I can't stop the 20 minutes it's going to take you to see the error. I can't stop the 30 minutes plus that it's going to cost you to repair. But what I can do is I can reduce the amount of time to less than 5 minutes it takes you to access the data, perform the analysis, and determine a best repair path. And this is how we're applying Snap to Industry 4.0 Human, the way we're developing products, and then saying what is the value for the end users. And Shawn, that's actually what I wanted to leave you guys here with today. I wanted to leave you guys here with today the concept about how we at PROCENTEC approach the market. And just to summarize, we approach it looking at humans as being a necessary part of the process. We then approach it from the standpoint of what does a human have to do? That's the troubleshooting process. What challenges they're going through, which is the current pyramid with staff shortages, as well as how do you get your resource knowledge as quickly as possible to being experts. I've discussed with you guys and showed you guys what our portfolio looks like, how we're getting data out actively and passively, and why it matters. Again, using the analysis of a doctor, active, the doctor's asking you questions, passive, the blood test combined, we can see basically everything that's going on in a network. And then saying there's solutions on the market to help you be more efficient in those 5 steps, specifically steps 2, 3, and steps 4. So where we can help you be more efficient is on the right access to data, performing the analysis, and then the best repair path. I walked through your users about what we could identify using those 2 methods and what the network structure would look like. And then I wrapped it back together with the value. So what do our technicians see that it takes a typical technician to get through those steps? And then how do we get full coverage at a very reasonable rate? And then what is the value for a typical operation that has a high cost of downtime? And that's what I wanted to leave your users with today, Shawn. And I hope that I've done that.
Matthew, I appreciate you going through that. And I'm going to ask you a question, and I'm going to
Sure.
pose it from the perspective of a listener who is managing a very large industrial automation network, whether it be Ethernet IP or Profinet. And
Yes.
they know that when they have network problems, it costs them tons of money. It takes down, different lines, and it requires all hands on deck, and you don't always have the right people available.
And so they've just sat through this podcast and like, you know, this looks like it may be a solution worth investigating because of the pillars and how that the time from when you know you have an issue to the time you're actually fixing it is shrunk greatly. And
Yes.
they're going to have a couple of questions. Number one, they're going to want to understand, like, who would they, like, if they want to know more, like, they understand the concept now. Now they want to get an idea of the nitty gritty, like, what would I have to do to implement this? Like, who are they going to contact to get that kind of information? Is it you? Your information is for the audio audience. The information is up on the screen right now. Matthew's information is. Will they be contacting you or emailing you and you putting them in contact with the right people?
They can email me. Yes. They can also. I would say it's a good start to email me. I could see your point. I did put up there my mobile phone and my email address. But they can also go to PROCENTEC's website, which is www.procentec.com, and they could contact, say, a local distributor, or what I would say is makes the most sense is to contact Jonathan Machin, who's our global sales manager. The reason why I say that is because Jonathan and I work together with the third member of our team, and him and I have done this with clients before, so we have everything down basically as easy as we can. We're ready to answer the questions that they're going to have, such as what data is staying off site, what does the design look like specifically for my operation. So that's what I would say the best way to contact. Reach out to myself, but they can also go to our website and contact Jonathan Machin or a local distributor. And then we would walk them through the whole process. So we're ready. The way the process typically works is we have an introductory meeting where we understand what they're trying to accomplish and where. Usually users would like to do a pilot, which again, we're used to. We have our technicians install, and then we get their technicians used to it. We build a case for that value. Really, what can we save you? And then based off that value, we would talk to you about a scale-up process. What is a strategy for scaling this up? What we see to get through most companies, that process could be 3 to 6 months typically.
Okay, so what we're
and then you guys are up and running.
Well, so I was going to say is what we're going to do is for our audience is we will provide a link in the description that will get you right to the website, right to the right place on the website. We'll also get you a link that will help you find your local people so you can start the process. If this seems like a solution you need, we'll put those links in the description so that you will be able to. And again, Matthew said you can email him too. He is in Europe, as he said at the beginning of the show, and I know a large portion of our audience is here in North America. But if this is something you would like to take farther or know more about, check out the links. They should be propagated to all the services that you can listen to this and watch this on, and you'll be able to go forward with that. And Matthew, I want to thank you for taking time out of your busy schedule to come on the Automation Podcast and tell us about not only your company but how you're solving solutions today with your 4-point human solutions.
Absolutely. I appreciate it. I mean, I appreciate your time as well. And, sometimes your audience might just want to have a conversation and see what's going on in a market. That's also okay. I regularly just have regular conversations and contact with people. So feel free to reach out. And if there is an interest in Snap, as I said, we've done this, we've deployed it. We've got a lot of the stuff already documented. So what I can say, and I want to leave your audience with is, the longer you wait and the longer that you don't have a strategy in place, it's just lost revenue. It's just struggles for your team. And why go through all that if you can implement something that gets you to a higher level operationally, and as I mentioned, is at a very low cost operations and a high value when it comes to return. So thank you very much.
Well, I hope you enjoyed that episode, and I want to thank Matthew for taking time out of his busy schedule to come on the show and bring us up to speed on PROCENTEC's For That Human and Snap Industrial Ethernet Fault Identification System. Now, with that said, if you're watching the video edition, please consider giving us a like and a sub. And if you're watching the audio-only edition, if you could give us a 5-star review, that'd be great. It really helps us find more people to watch the show, as well as more vendors to come on the show. Now, if you've already given us a 5-star review, I want to say thank you. I know several of you have done so far, so thank you very much. Now, if you're looking for my affordable online training courses, you'll always find those over at theautomationschool.com. And if you want to follow me and optionally support us, you can do so over at automation.locals.com. With that said, I want to thank you for watching and wish you all a very safe, happy, and healthy week. And until next time, my friends, peace.